Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, we're going to be creating here a Pharma Query RAG agent system using Python and Langchain. So without wasting any time, let us start our tutorial right now. In order to building here our Pharma Query agents, we are to uploading here multiple number of PDF files. It's mean we are going to processing here our document as well as we're going to retrieving the information from those document as well as using the large language model. It's mean we are directly using here the RAG system. So the RAG stand for Retrieval-Augmented Generations. Here R stand for the retrieval. Let's say retrieval. So retrieval, it's mean retrieving something or some information from the vector store database. So let's say vector store database. So from database, you basically fetch the data directly. Then this A for augmentation and G for generations. So we are going to using here actually the large language model. I mean, you're going to using here free and open source model from Grok, okay, like a llama, or you can also using here whisper model, or you can also using here the DeepSeek R1 models. Now first see how can we basically processing here our documents, I mean the PDFs. So it's called the document ingestions. So here we actually uploading here our document in the from a PDF. So in our case, we have the multiple number of PDF we can upload, and then we need to also process it from process it in the plain text. I mean, in our PDF, it maybe have the multiple number of pages. So you need to also process them as well as you need to convert them into the textual format. So in this case, you can using here any kind of module. So you're going to using here the PyPDF. Okay, you're going to using here this PyPDF module. So using this PyPDF module, you actually basically process it easily. Then after that, we need to converting the textual data into some kind of chunks. So chunks is nothing but mean the pieces of the data. So and that is simply going to pass it to inside our Hugging Face embedding, so that it will creating here one vector is stored for the text data that is coming from these text chunks. So see, the text chunk is not even consisting of the LLM context itself. Then you're going to store it inside our vector store database because you're going to using here the RAG system indirectly. So we are going to using here FICE or the ChromaDB. So FICE is nothing but one kind of semantic search system for the Facebook AI similarity, and as well as we can also using here the ChromaDB. So in our previous video for the Amazon financial RAG, we basically using here this FICE, and now in this one you're going to using here this Chroma vector database. Now you can see here we basically processing here our document, but we are not designing the retrieval yet. So also you need to also retrieving the informations from the database. So what you can do, we're simply going to asking a questions. Let's the user asks a questions, and based on these questions it will creating here one question embeddings. So for that we basically using here the Hugging Face as well. We can using here the Hugging Face embedding, and then we're simply going to creating here a question embedding, and from this data store we basically search based on cosine similarity. If you don't know what is the cosine similarity, you can go and check out the videos about the movie recommendation system, how we actually discuss everything about the cosine similarity. Then after that we have our the LLM context, I mean our text chunk itself. So this is also a text chunk, and from this text chunks it will try to accessing all the informations and it is passing to our large language model. So from here, you can also retrieving the informations. You can retrieving the information directly from the database. But here we actually basically using the large language model so that our the question answer is generalized and we can get some better results as well. And after that, we got our final response. Okay. So this is nothing but the RAG pipeline that how it actually work. Now let's see what are the module that you're going to using here. Okay. So you're going to using here some of the module I already explained on here. I mean, write it down. So first module is about the Langchain. So the core Langchain package for chains and prompts. So you know that while you're going to creating here our GenAI projects, you need to also give here some prompt because it's indirectly using here the large language model itself. Then you need to also creating here some kind of chains. It's called the RAG chains using Langchains. Then we have our next package called the Langchain community. So or you can say modules. So it's contain here the integrations like Chroma and document loader. So you directly import the Chroma DB as well as the document loader like the PyPDFs from this Langchain community. It's already built in inside these modules. Then you have the Langchain core, and inside this Langchain core, it's basically used for internally for runables, prompt, and parsers. Okay, it's nothing but for the pass of the data, and this prompt you know that for creating the prompt tablet, and parser is parsing some kind of string and output parsers. Then after that, we have our Langchain Grok. So using Langchain Grok, we basically integrating here the Grok's LLMs into the Langchains. So Grok is free and open source model. We can basically use it, and we don't need to pay it for that. If you're using the OpenAI, so you need to obviously pay for that. Now we have our Chroma, that you can see Chroma. So Chroma is a back-to-rest database. It's basically used for the semantic search. Then you have the sentence transformer used for actually Hugging Face embedding model. So you're going to using here this all MPNet based B2. This is our model that you're going to using here for creating here the embedding, and it's also the free and open source. See, we are going to using here free and open source model for the learning purposes. Okay, so if you have the money, and you can easily purchase here actually the OpenAI the API key as well. So, okay. Then you have the Langchain Chroma. So it's nothing but the Chroma DB is already available inside this Langchain Chroma as well. So it's nothing but a backdoor DB using for Chroma for storing and retrieving the documents embeddings. Then the last one is called the Langchain text splitter. So you see that in the documents, when you process documents, you need to also divide them into some kind of chunks, or need to make some pitch of chunks. So you can basically using here this Langchain text splitter to text splitting tools optimized for LLM processing, so that you can creating here some kind of chunks for that. Okay, so those are the module is needed to creating here our projects. Now you're simply going to go on the Google Colabs. You can basically using here your own machine as well. I'm just going to using here my Google Colab, and after that you also creating here an interactive UI using the Gradio library. So let's start and go on our Google Colab. Well, so right now we are in the Google Colab. So let's first installing here the required library. So first you're going to installing here the Langchain Chroma, then Langchain Grok, Langchain Core, Langchain Community, and Langchain Text Splitter. Okay, let's try to using here Shift and Enter. So it will installing those module. So it will obviously taking few times. Let's go down. So we are going to explaining all of this code line by lines. Okay. So let's wait for a few seconds so that it will install it, and after that we will continue our discussions. Well, so our installation is done, that you can see. Now let's explain all of the code line by lines. Okay. So first you import here the OS. It's basically for file system interactions. You can create the files. You can create the folder as well. Okay. Then we also import from Langchain Grok. We import here the chat Grok, so that you can accessing here our Llama model. You can also using the DeepSeek R1 model as well as the distillation ones. Then from Langchain underscore core dot prompts, you're going to be importing here the chat prompt template. It basically formatting here you prompt with some kind of placeholder. So you can using here placeholder like questions. You can using here a placeholder called the context. Then we have the output parsers. So you can see from Langchain core dot output parsers, you can import here this string output parser. It basically helps extracting here the raw string output from the models. Then we are going to import here the Langchain underscore core dot runnable. We import here this runnable pass through. So it actually help us to pass through the utility for the Langchains. Then this Hugging Face embedding from this Langchain community. So Langchain community dot embeddings, we import here this Hugging Face embeddings. So it's basically used for embedding generations using the Hugging Face. Okay. And then you have the Py PDF loader that you can see from Langchain community dot document loader. We import here these Py PDF loaders. So using this Py PDF loader, we basically loading here the PDF file directly. You're not going to using here the docs file yet. We are going to using the PDF files. That's why I directly imported here this Py PDF loaders. Then from Langchain underscore text underscore splitter dot sentence transformer, we actually import here this sentence transformer token splitter. So it's nothing but one token based text chunking technique in the case of sentence transformers. Then you have our Chroma DB. I mean, from Langchain underscore Chroma, we import here the Chroma. So Chroma is a back to restore for the semantic search. Now you can simply go to Shift Enter and wait for that if we got here any kind of error or not. See, it's run. That's been successfully installing all of the library. We don't any kind of errors as well. So, okay. Now we need to creating here a directory for persistent DB. See, when you are actually using here the Facebook AI simulated search back to the database, you don't need to creating here any kind of directories. But when you are using here the Chroma DB, you need to creating here a directories in your working directory. So you're going to using here os.makeDirs, and you're going to give it here and directory name, and you also give it here exist is okay equal to true. It's mean if it is exist, it is not going to create it, but if it is not exist, it will directly creating here a folder. So if I reload it, then you can see a folder is created called pharma_db. Then after that, we need to actually initialize the embedding models and the backdoor DB. So what you can do, basically, you're going to call in here this Hugging Face embedding. Then you're going to give it here our model name. It's called sentence transformer all MPNet base B2. That's our embedding models. Now after that, we're simply going to initialize here our backdoor DB. So our backdoor DB is nothing but our the chroma DB itself. Okay. So you can see we pass here a collection name that's called by pharma database. It will creating here a collection names called the pharma database. If you know that what is the collections actually in the case of NoSQL data, you obviously know that. Then we have our embedding function. So our embedding function is nothing but our embedding model itself. Then we have our persist directory, where it will actually basically store it in the form of persist of the chroma db. So we give it here the pharma db. That's our this name as well that we actually created. Okay. Now you can simply go into using here the shift enter. So it will initializing this one. It will be creating here. I mean it will downloading this the embedding from the internet. It basically taking from the Hugging Face that you can see sentence transformer MPNet base 2 P2 sorry. So you can also using here the OpenAI the embedding, but for this case you need to pay for that. Okay, because this is a paid version. So this is a free one. You just use it for the education purpose, but when you are doing it for the commercial purpose, so make sure you are using the OpenAI. Okay. So now you can see it will downloading some of the module.json. It will configuring here the sentence transformer.json file, as well as it will downloading the embedding model. So this embedding model is basically used for actually back to restoring your textual data. Okay. Now we're simply going to create here an prompt templates so that you can see. So it's actually you should define the how the from prompt should look like, that you can see. So it's remove the it's basically it's not actually it's actually remove the fluff like actually according to the context actually. So you can see you are a highly knowledgeable assistant specialized in pharmaceutical science. Okay. And answer the questions based on the following context. So you can see the context. Okay. It's nothing but one kind of placeholders that he already told you that what is the use of this chat prompt. Okay, that you can see here you go, this chat prompt templates. So you can see some kind of placeholders. So answer the questions based on the above context. You can see the answers. So use this provided context to answer the user's question accurately and concisely. Don't justify your answers. Don't give informations not mentioned in the context informations. Okay. So don't say according to the context or mentioned in the context or similar like that. Okay. So you're going to using this chat prompt template. I'm going to using here dot prompt template. We passing here our prompt template itself. Then you're going to using here the string output person so that it can parsing the information. Okay. So now let's try to shift enters. So it will execute it as well. Now you need to creating here a helper functions to format here our retrieval documents. Okay. So that's why you're going to creating here functions called format docs, where it will taking here the docs itself. Okay. So you can also show here the your output person if you uploading here any kind of PDF, but I am not going to show it yet right now. Okay. So and after that we're simply going to processing here our PDF documents. So for that you're going to creating here a functions called dap. Sorry, not we are not discuss it yet. See, we have our functions called the format docs actually. So returning here the document dot page content. So how you basically converting here your documents is nothing but a list of document chunks, okay, into a long text block in a large language for large language inputs. Okay. So you are going to passing here this data in the form of chunks. So you just format the documents. Okay. Format the chunks into some kind of long text block. Okay. That's why you can see we added to all the below from here, because this is nothing but an list itself. Okay. This is the docs that you're going to passing it from here our main functions. Okay. Don't worry, we will discuss everything one by one. Then after that we're simply going to uploading here the document. We need to also process them. So you're going to creating here functions called process document, which one is taking here a file path. So if the file path is available, then you're going to using here this py-pdf loader. So directly passing here a file path, which one is coming here in the form of arguments, and we have our loader. So you're going to using here this loader.load, and that's our data. Now from this data, we're extracting here our metadata as well as our contents. See, two things: one is the metadata, another one is the contents. So we extract it from the data itself, that's our loaded, and as well as we also taking here the page content, which is doc content itself. And after that, you're going to using here our sentence transformer token splitters. And here we need to passing here our model names. So our model name is sentence transformer all mpnet base p2, and then you give it here the chunk size. So chunk size is just give it here 100. I mean, it will taking here the first 100 word and it will creating here a list, and after that it will taking here the another one, and after that it will taking the another one, like that. I mean, it will converting here a full text into some kind of chunks, some kind of pieces. I mean, pitches. Okay. So then you're going to give it here chunk overlap. If the chunk is overlap, you give it here the 50. And then you give it here the text splitter dot create the documents, and we passing here our docs content, as well as we give it here our doc metadata. And then we simply going to store it inside our db. So db dot the add document, and we passing here our chunks. Okay. So our db is here that you can see. So here is our db. I mean, our process data is stored it inside our db. So in the summary, we load here our PDF files, we start in the content and the metadata, then we split into the overlapping chunks, so split into the overlapping chunks, and then we store the chunks into the ChromaDB. Okay, that's our main summary of this process document functions. And after that, we are going to creating here our RAG query functions. Okay, that's you can see. So you have our functions called run query, and here you passing here our query and our Grok API itself. Okay. So then we have our retriever. So db.asRetriever. I mean, you are retrieving the data from our informations from our data stores. Then you're going to using here the search type as the similarity. I mean, the cosine similarity. And you also give it here top 5 of the information is coming up. And from this 5 top, you're going to taking here our best results. Okay. Then we have our LLMs that's called ChatGrok. Here we initialize here our Llama 370me8192. You can also using the DeepSeek model itself. Okay, no problem. Then he creating here the API key and temperature is equal to 1. Now we're creating here our RAG chains. So in our RAG chain, we passing here our context as well as we have our questions. So in the case of context, we actually creating here and chains between the retriever and the format docs. I mean, this format docs functions, okay, which is taking here and docs itself. So it is nothing but a chain. And then our question is coming from the runnable pass-through. So you're going to creating here a chains about the runnable pass-through, the prompt tablet, the large language model, and the output parser. Okay, that we created. So our output parser is nothing but our string, our string output parsers. This is string output parsers. That's our output parser itself. So that you can see. So how is it? We don't initialize the outputs yet. I need to initialize it maybe. Let's see. Okay. We also initialize it maybe. Yeah, you can say output parsers. Okay, fine. Okay, now after that, you need to invoking here using our RAG chains. So you can say RAG chain.invoke and we passing here our query itself. So in our questions, we create the chains about the runnable pass-through. We create the chains with the prompt template. We create the chains with a large language model. We're also creating here the chains using the output parsers. Okay, that's it. Now, we need to also calling this after right now. So you're creating here and main functions. Here you have our main function itself. Then we basically give it here some kind of PDFs. Okay, that's simple PDF 1, sample PDF number 2. Then we actually calling here our process document. So it's better you can uploading here some of the sample PDFs. Okay, so I can say that let's upload this one. That's the AI drug discovery, as well as let's say the vaccine development workflow. Okay, let's click on open, and now let's click on OK here. Okay, so let's copy this out, and then I am simply going to paste it to here. Okay, that I'll show you how it actually work. That's why I just give it here sample to .pdf. I'm actually testing this out, right? So let's copy this out, and I'm simply going to paste it to here. Okay. So now we need to run a query. So I also give it here some of the comments so that how I'm actually uploading here this code in the GitHub so that you can also understand that. Okay. Now after that, you need to give it here your Grok API key. Now here you can actually basically get it. So you can need to go inside this Grok Cloud API. So Grok Cloud, and then you can have this Grok Cloud. So you can also using the DeepSeek kernel model. If you're not using here the Chinese AI model, you can basically use that. That's not a big issue. So now you can go inside this API key sections, because we need here our API key. It's free to use, but it also have some kind of limitations as well, right? So let's go on the API keys. Now let's click here to create API key. So to give it here an API key, so let's give it to here the Pharma. Okay, let's say Pharma query. Like that, you can give it here any kind of name. And after that, it will be verifying that you are human or not. So stack here. Okay, I need to waiting for that because maybe my internet connection is so slow. Okay, so creating here our API key that you can see Pharma query. Now you can basically go on here and you can basically paste it to here. So you can pasting here your Grok API key. I'm just going to paste it to here. Don't worry, you cannot use this one because after making this tutorial, I'm just going to delete it from my the accounts. Okay. So after that, you can see you can also go inside this docs. Then you can also selecting here the models. You can see here you can using here this Llama 3.3 17 billion versatile. You can use any of them. Let's using these ones. This model, this Llama 3.317 million versatile, as well as you can also using the DeepSeek R1 model, as well as you can also using this Gamma 29BIT. Okay, so let's go on here now, and then you are going to asking here questions. What are the AI application in drug discovery? Okay, then you can see answer is equal to run query. We basically using this rack chains that we have, and after that we have our users query and the Grok API key that you're going to passing on here. Now let's using here the shift enter, and obviously to give me some kind of errors. Okay, it's a process document is not defined. Okay, so let's see process document. So our process document is not defined. I think we are not running it yet. That's my bad actually. So now we can basically run this out. Okay, so PyPDF package not found, so please installing here the PyPDF. So in it also internally installing here this PyPDF module as well. So I'm actually installing these ones, I mean installing those modules. So you know to using here this PyPDF module as well. So let's shift enter. It may be happen. Okay, so you can see requirement already satisfied, as well as it installing here the PyPDF package. Okay, so now let's go on here and simply running this out. Okay, you can also using the stream so that it look like the actually the chat gpt format, streaming format. Okay, error message invalid API key, invalid API key, say invalid API key. Okay, so let's replace our API key. Maybe some bad request we may get, so let's replace it. And then I'm simply going to running here the query. Our user query is what are the AI applications in dark discovery, and then you have our run query methods that you can see, and then you can simply going to run this out. Let's say run it out. Okay, now it will process them and it will also give some answers. So you can see AI application in drug discovery include here the identifying the promising drug candidate by analyzing the large chemical database using machine learnings, then predicting here the molecular interactions and drug target affines using deep learning models. It's basically coming from this AI in drug discovery. Okay, now what I can do is simply going to creating here an interactive UI. So for that, you have to actually using here a library called Gradio. So let's say pip install, let's say pip install Gradio. So let installing here this UI library. So you don't need to writing here much more amount of code. You have to building here this kind of applications. So I just run it out. It will install them. Yep, installation is finished. Now you can see we also import here those kind of modules that you already discussed, the OS, the GradU, the chat grok, the chat prompt template, string output parsers, the runnable pass-through, the Hugging Face embedding, PyPDF loader, and the sentence transformer and ChromaDB. Same thing, all of the code I just edit, and after that finally you're creating here another function so that you can running here our GradU interface in functions. So we have our functions called Pharma query interface, which is taking here the query as well as it is taking here is Grok API key itself. And after that, we simply going to calling here our methods called the process documents. And if you don't give here your Grok API key, so obviously it will show you that please enter a query and your Grok API key. Then to running here your query, I mean this run query method, that's our creating the reaction for run the query through the reactions. And then you're also creating here an interface. Here you basically passing here our functions called Pharma query interface. And then you have our gr.text box. Here you have our pharmaceutical questions and placeholder example what are the application in drug discovery. Then it have the text box, let's say Grok API key. Then you also give it here some type, let's say password, so that you don't see the Grok API key. Then you have the gr file, and you're simply going to get here labels, let's say upload PDF documents. This one is optionals. Okay, if you want to do it, you can do it. You can using here the multiple number of PDF files. Okay, without the PDF file, you can also access the questions. But if you are uploading here the PDF files, it will directly calling here these RAG chains. Okay. Now after that, you have the output. So output is used in the RAG answers and lines of tans, and then you give it here title Pharma Query RAG for pharmaceutical science. Then descriptions, as well as you also launching here our KD applications. Now let's running this out. So after that, it will taking few seconds. Then it will give here one link. So here you can basically accessing here your Gradio applications in live. So that you can see, I can simply going to click here to the live. So here you can basically asking the questions. Okay. So you can go on here as well. So you can see. So here you go. Okay. So you can remove this right now. You don't need it at all. So it will taking few times to loading this up, that you can see loading here the UI. So you can also add here some custom themes which is available in the Gradio website or documentation. You can easily get it from here. Now what I can do is simply going to give it to here our API key or in our UI is loaded. So you can see pharmaceutical questions that you have your Grok API key. Let's give it here our Grok API key. And after that, you're going to uploading here the file from our folder that you can see. So let's upload here a file for let's say these ones. Okay. So you can uploading it. Let's say you can drag and drop. Maybe I cannot drag and drop my this the taskbar is closed. So I need to click on here, and then I can choose it from here. Okay. So let's click on here to open. Now it will uploading. You can upload here the multiple of files as well. Now it's asking here equations, then it will the rack actually give you the answer for that. Okay. So all of the question is store it inside a text file that you can see. So I can open it in the notepad. So we uploading here this the second one maybe. Okay, this one, fourth one. So how does this CRISPR help in gene therapy? I just asking the question from that. Okay, here you go. And then I'm simply going to paste it here and click on submit. I just write down some of the questions. Okay, we got some error. Okay, maybe my Grok API key is not correct at all. Okay, I need to go on here again. So I need to copy here this Grok API key that we have it. Okay, so let's go on here. Now let's give it here the Grok API key. Now let's click on submit. Okay, now you can see got the answers. Okay, CRISPR helps in gene therapy by correcting mutation responsible for genetic disease like this. Okay, now you can also uploading here the another questions in another files. Let's uploading here role in pharmacovigilance. Okay, let's click on open. And then let's go on here. Okay, not here actually. Now let's taking on actually questions from here. So these questions, just click on here, and then we're simply going to paste it here our questions, and then click on submit. Okay, we maybe got so many kind of error actually. So I don't know why this kind of thing actually happening. Yep, it processing. Sometimes it taking time. Maybe today maybe there's doing some kind of updation in the Grok cloud. So sometime the API keys unable to access, and sometimes not. I don't know why actually. Maybe they're doing some kind of working in their website maybe. Okay, so you can see this is the rack answer in 10 lines that you can see. So this is how our pharma query, the rack for pharmaceutical science actually is actually work. So congratulations to everyone who is successfully creating here our Pharma Query RAG agents. Now, finally, let's see the pipeline of the RAGs. So this is a pipeline RAG pipeline flowcharts that how we basically creating here our full applications in a flowchart way. So first we have our PDF files. It may be the multiple number of PDF files, so you can upload it. And after that, we stacked it here using here, stacking the text using the PyPDF loader. And after that, you have our text. Then we split the text splitter. So it having the chunks plus overlap. Then we apply here the Hugging Face embedding. And after that, we store it inside the ChromaDB. And from the ChromaDB, we are going to retrieving the top k chunks. And after that, we format the documents, I mean, from the docs. And after that, we have our prompt template that you can see. Then you're using the chat grok LLMs. We access the grok cloud API from the grok cloud and using the llama models. And after that, we're using this string output parsers. And then finally, you got here our answers. That's our RAG pipeline. So if you see the summary, so that's our summary. So PDF are loaded, then split into chunks, then we convert it into the embedding, then saved in ChromaDB, and user asks questions. So top cache similar chunks are retrieved. I mean, let's say 5 chunks is retrieved, the similar questions, and from that, the chunks are used at context in a prompt. That it is sent to the clocks LLMs, and LLMs generating here and grounded response and printed to the user that you can see in the actually applications. So this is the whole summary of the full tutorials, and this is the flowchart that you can see. Okay, so that's it for today. Now I hope you enjoy this full tutorial, and make sure to subscribe my channels as well as share with your friends so that they can also learn about the GNAI, because right now this is the world of the NLP and the GNAI. So thank you and bye bye.